astronomers might have solved the mystery behind an unusually brightening star. University of Washington doctoral student Anastasios Tsanidakis and research assistant professor of astronomy James Davenport were searching for stars behaving strangely when they received an alert about a potential stellar oddity from the Gaia spacecraft. Hello and welcome to KYC News. Please don't forget to subscribe and hit the bell icon. The Space Observatory, launched by the European Space Agency in 2013, is on a mission to create the most precise 3D map of the Milky Way galaxy to date. The astronomers focused on Gaia 17 BPP, a star that had gradually increased in luminosity over a 2.5-year period. The results of their investigation and analysis of the star, shared Tuesday at the 241st meeting of the American Astronomical Society in Seattle, revealed that the star itself didn't change. Instead, the star has a strange companion responsible for what the researchers estimate to be a 7-year photobomb. We believe that this star is part of an exceptionally rare type of binary system between a large, puffy older star, Gaia 17 BPP, and a small companion star that is surrounded by an expansive disk of dusty material, said Tsanidakis in a statement. Based on our analysis, these two stars orbit each other over an exceptionally long period of time, as much as 1,000 years. So, catching this bright star being eclipsed by its dusty companion is a once-in-a-lifetime opportunity. The Gaia spacecraft began observing the star in 2014. The researchers pulled together all of Gaia's observations of the star and tracked down other observations of Gaia 17 BPP that were taken by Pan-STARRS 1 telescope in Hawaii, the NASA WISE/NEOWISE mission, and the Zwicky Transient Facility in California going back to 2010. By comparing the images of Gaia 17 BPP, the researchers determined that the star's brightness dimmed by 4.5 magnitudes, or 67 times. It remained this way for 7 years, from 2012 to 2019. The astronomers just happened to observe the star at the end of an eclipse that lasted for years. No other stars located near Gaia 17 BPP have exhibited any dimming of this magnitude. The team also searched through a digital catalog of astrophotographic plates at Harvard University dating back to the 1950s. Over 66 years of observational history, we found no other signs of significant dimming in this star, Tsanidakis said. So what happened to Gaia 17 BPP? Based on the data currently available, this star appears to have a slow-moving companion that is surrounded by a large disk of material, Tsanidakis said. If that material were in the solar system, it would extend from the Sun to Earth's orbit, or farther. Although Gaia 17 BPP is unique to have such a long eclipse, it's not the only binary star system to showcase dimming behavior. Astronomers are also intrigued by Epsilon Aurigae, a star that experiences an eclipse for 2 out of every 27 years by a large companion, but the actual identity of the companion remains a mystery. The giant star Betelgeuse also attracted attention from astronomers when it dramatically dimmed in late 2019, inciting speculation that it was going to explode into a supernova. Instead, the star had a dusty tantrum. For Gaia 17 BPP, the dust-making stellar companion could be a small dead star called a white dwarf, but they aren't quite sure what could be contributing to the disk of debris around it. Whatever the identity of its companion is, Gaia 17 BPP and its mysterious cosmic partner are so distant from one another that another eclipse is centuries away. This was a serendipitous discovery, Tsanidakis said. If we had been a few years off, we would have missed it. It also indicates that these types of binaries might be much more common. If so, we need to come up with theories about how this type of pairing even arose. It's definitely an oddity, but it might be much more common than anyone has appreciated. New research by an international team of astronomers solves the mystery of hot blue stars, which despite their smaller size are especially luminous. Astronomers have solved a mystery over small, unusually hot blue stars, 10 times hotter than our Sun, that are found in the middle of dense star clusters. The international team found the so-called blue hook stars throw off their cool outer layers late in life because they are rotating so rapidly, making them more luminous than usual. We've solved an old puzzle. These stars are only half the mass of our Sun, yet we could not explain how they became so luminous, said team member Dr. Antonino Milone from ANU Research School of Astronomy and Astrophysics. As the star was forming billions of years ago from a disk of gas in the congested center of the star cluster, another star or stars must have collided with the disk and destroyed it. The research, published in Nature, gives new insights into star formation in the early universe in the crowded centers of clusters. Star clusters are rare environments in the universe in which many stars are born at the same time. The team studied the globular cluster Omega Centauri, the only cluster visible to the naked eye, which contains around 10 million stars in close proximity to one another. The model shows the formation of stars in clusters do not all form at once, said co-author Dr. Aaron Dotter, also from ANU Research School of Astronomy and Astrophysics. These blue stars must form in a second generation of star formation, he said. Our new explanation is quite simple, and it hangs together really nicely. Usually the large disk of ionized gas around a newly forming star locks its rotation through magnetic effects. For the progenitors of blue hook stars, however, an early destruction of its disk allows the stars to spin up as the gas comes together to form a star. Because its high rotation rate partially balances the inward force of gravity, the star consumes its hydrogen fuel more slowly and evolves differently throughout its life. The blue hook phase of its life occurs after more than 10 billion years, when the star has consumed nearly all its hydrogen and begins burning the hotter fuel helium. The different evolution processes leave it with a heavier core which burns brighter than typical helium-burning stars. Based on our analysis, these two stars orbit each other over an exceptionally long period of time, as much as 1,000 years. So, catching this bright star being eclipsed by its dusty companion is a once-in-a-lifetime opportunity. The Gaia spacecraft was launched by the European Space Agency in 2013 and aims to create the most precise 3D map of the Milky Way galaxy to date. It started observing the star in 2014. Gaia's observations of the star put together with other observations of Gaia 17 BPP taken by Pan-STARRS 1 telescope in Hawaii, the NASA WISE/NEOWISE mission, and the Zwicky Transient Facility in California going back to 2010, led to the final results. The astronomers simply happened to catch the star at the end of a years-long eclipse. Its brightness dimmed by 4.5 orders of magnitude, or 45,000 times, for 7 years, from 2012 to 2019. None of the other stars near it displayed a similar activity. Over 66 years of observational history, we found no other signs of significant dimming in this star, Sanadakis said. Based on the data currently available, this star appears to have a slow-moving companion that is surrounded by a large disk of material, Sanadakis said. If that material were in the solar system, it would extend from the Sun to Earth's orbit, or farther. There are other binary star systems that show a similar behavior. A star in the Epsilon Aurigae experiences an eclipse for 2 out of every 27 years by a large unknown companion. The giant star Betelgeuse also became the center of attraction for astronomers when it dramatically dimmed in late 2019. Experts thought that it will explode into a supernova, but instead it experienced a titanic surface mass ejection, wherein it lost a substantial part of its visible surface. An alert about a potential stellar oddity from the Gaia spacecraft might have solved the mystery behind an unusually brightening star. University of Washington doctoral student Anastasios Tsanidakis and research assistant professor of astronomy James Davenport, who were searching for stars behaving strangely, had been focusing on Gaia 17 BPP, a star that had gradually increased in luminosity over a 2.5-year period. The two made their probe public at the 241st meeting of the American Astronomical Society in Seattle on Wednesday. They revealed that the star hasn't changed, but it has a strange companion responsible for what researchers call a 7-year photobomb. We believe that this star is part of an exceptionally rare type of binary system between a large, puffy older star, Gaia 17 BPP, and a small companion star that is surrounded by an expansive disk of dusty material, said Xanadakis in a statement.